now we come to our proofing stuff. We promised that we would prove with our proofing tool that we were right. First, these two gave the same value. The L was equal to 11.18 feet. Now we are going to prove it with another tool. First, we will use this one and we enter it in our tool and check our answer. I'm bringing up the tool. Let's go to GeoGebra. GeoGebra is a good tool for us to work on, and let's input the value of our function here. We said it was 8 over cosine of let's call it x plus 1 over plus 8 over sine of x, I think. Of x plus 1 over cosine of x. Alright, so we hit enter. That is our function, and now we have to take the derivative of function of f of x. So we say derivative of f of x. Let's see if we will let it go. Alright, he was sketching our derivative f prime. Let's change its color to see what is happening in the graph here. Color, we use blue for now. Okay, so the derivative is in blue and the other one is in black. Now let's see the minimum. This is the minimum of this function, the derivative, but when it is 0, this is what we are interested in. When the derivative was 0, it is catching here, it is catching here. So we take that value at the function itself was also 0 here. So let's see. Let me bring this up. Alright, let's find these points. Intersection of these two here. Alright, this is A. So when we have A here, we can take a line through that point, which is perpendicular to another one. Let's take perpendiculars. Alright, we pass it through here, and we select that. We can see that it is meeting this function at its minimum here. We mark that point. That point is B. So if you look at the coordinates of B here, B is 11.18. This is the value of our function. This is what we found. The length is 11.18, the minimum value of the length. Alright? Thank you. A quick check now with our algebra equation here. What we kept our trigonometric function, it worked. Let's check our algebra equation. and we have used our tool. I'm bringing up GeoGebra. So we have GeoGebra here. Let's put it in the middle, and let's enter our function of the length. It was square root, we said. Square root of x squared plus 64. Now we added to that L2. L2 was square root of 1 plus 64 over x squared. It has been graphed for us, but we may need to just do a little bit of, you see it is here. Can do like this. Alright. Now let's take its derivative, first derivative. This is the first derivative. As we did in the other side, let's change the color. Let's make it red this time. This is the derivative. The derivative is 0. This time we have it somewhere here, you know. So it's 4. We know that x was 4. Alright, so let's mark that point, intersection. That's A. Alright. Now let's find the perpendicular as we did last time to the x-axis. There you go. So we are coming to here. So let's find this perpendicular to see, actually if we mark that point, we will be its coordinates. The y coordinate will be our value of that function here. This is the minimum actually, but let's see, find a point, intersection of these two. B, if you look at B here, B is intersecting that function at 4 and 11.18. So that's all we had to prove. Thank you very much for watching. Thank you.